Air conditioning means taking heat from where it's not wanted and throwing it where it doesn't matter. We start at the compressor. The compressor has two ports, an inlet and an outlet that goes into a coil outside, which is your condenser coil. From there you have your king valve and a metering device. Past that we have the evaporator coil that's on the inside, going back to the condenser through a king valve. And that's the entire refrigeration cycle from your condenser to your evaporator. Step 1, the compressor compresses. And that's where we're going to start because the compressor is the heart of the system. So the compressor takes refrigerant and throws it out as a high temperature, high pressure vapor going to the condenser. So we need to get rid of that high temperature with a condenser fan motor that releases hot air from the condenser, which makes the refrigerant leave at a medium temperature, medium pressure liquid. Once the refrigerant leaves the condenser, it goes back to the king valves, and that's where you connect your gauges. We'll talk about the gauges in a bit, but for now, the refrigerant is going to the metering device. The metering device produces something called flash gas by means of a piston or sort of metering device. It could be a TXV, but for now, we'll worry about a piston. That looks like a Decepticon, but this is what a real one looks like. You can imagine liquid refrigerant going through those tiny holes, the one in the middle and the ones on the sides, to produce that flash gas because it makes the pressure drop completely. Step number 2 is something very important, but you can't exactly check it. So whenever the liquid refrigerant goes through those pistons, the temperature and pressure immediately drop. So you have a low temperature, low pressure gas, but it's 80% gas, 20% liquid. Number 3, don't freeze, meaning don't allow the saturated temperature of the refrigerant to be below 32 degrees on the low side on the blue gauge. By that I mean, usually you're going to be working with 410A, so the pink numbers mean the saturated temperature of the refrigerant. So you're going to be looking at the pink numbers on the gauges. So the gauges are very important for the next step coming up, which is number 4. So we're flipping over to the red gauge, so it's outdoor temperature plus 30 degrees. Same thing, looking at those numbers on the gauges of saturated temperatures, add 30 degrees to that, and that should get you right around where you need to be. For this example, let's say the outdoor temperature is 95 degrees. So 95 plus 30, we should be at 125 degrees saturated, which on 410A would be around 450 PSI. I went ahead and drew it on these gauges with sort of what they need to look like. And if you notice, the low side is 30 degrees below the indoor temperature. So they have a direct correlation. So you want your high side at 450 PSI and your low side at 150 because that's 30 degrees above and 30 degrees below. Last step, number 5, is delta T, or the temperature difference between your return and supply. In this scenario, let's say the returner is at 82 degrees and the supplier is at 64 degrees. That gives us a difference of 18 degrees. So that's your delta T, 18. So your ideal range is between 16 and 20 degrees difference from your return and supply. Lastly, if you need to charge refrigerant, make sure you flip your drum upside down to ensure you're only charging with a liquid. The 410A is a blend of refrigerants, meaning that the heaviest one will settle at the bottom if you charge it with gas. So if you charge it with liquid, it'll be a pure blend. Again, it's liquid, so meter it in, meaning your gauges, you're gonna have to open and close slowly, open and close until you get the pressure you wanted on the low side.